Good afternoon, everybody, and welcome to Zan Academy. Today, we have a treat with Kris Schermerhorn, CDT, and the owner of Northern Virginia Dental Laboratory here. And he's going to be speaking about designing and milling flexible partials featuring Exocad and Myerson products. And he did this lecture for us at our Philadelphia roadshow in June with his son Logan, and it was so well received that I brought this up to the Myerson folks and Kris to please, we need to share this with our, Zan Academy people because I really feel that this is something that people are talking about, flexible partials, what to do, how to design them. So, Kris, I just want to thank you so much for joining us and being so gracious, and everybody over at Myerson for supporting this. We really appreciate you joining us back here at Zan Academy.
Absolutely. I always enjoy, sharing. It's the digital industry is kind of cool because I've been doing this for 30 plus years. And with the digital industry, everything's new in a lot of instances. And so we're all kind of learning together. And it's nice to share. I've always been a big believer. My father started the lab back in the 60s, so I'm second generation. And as you mentioned, my two sons are working in the industry. So if they continue with it, a possible third generation of doing this. And my dad was always a big proponent of sharing, helping kind of your industry out. And, I really enjoy that. And digital's fun because we're all learning every day. This new thing kind of in a way. So yeah, thanks a lot. And so what I'm going to talk about today is digitally designing DuraFlex, flexible partials. And flexible partials have their place in the industry. And a lot of people don't necessarily like working on flexibles done the traditional way. Now you get good at them. They can go smooth and they can be, as close to as easy as doing it as you would acrylic partial. But you got to spend the time to kind of get good at it. And doing things the analog way takes time. Whereas on the digital side, the learning curve and the reason the digital is so popular is it's just faster to learn. And so I jumped on really, really early with the digital design for flexibles before really Exocad or 3Shape had workable workflows. They were kind of workarounds all the way through the process. Now the softwares there's still some things I'll show you to kind of make things work better that are still some small workarounds, but there is a workflow in place for flexible partials. And we're going to show that today. And so I feel like I know Exocad really well. I've been using it for, 11, 12 years, but there's definitely people out there that know way deeper levels of Exocad than I do. I'm not really here to be an expert on Exocad necessarily. I'm here to be an expert on Exocad specific with the DuraFlex material. And I just want to show you like the little tips and hints and the things that I kind of learned, let you guys take advantage of me getting beat up on kind of developing this process over the years. So
Everybody loves those tips and tricks, right, Kris? So bring it on. I just want to quickly let everybody know that Kris will be taking questions. So please don't be shy. Type them into the Q&A and I'll deliver them to him so we can get your questions answered. And there'll be some polls at the end as well. So everybody enjoy. Thank you so much.
And definitely, as you guys know, when you're working with software, there's those times where the software has to work a little bit. So those questions are great to fill that time. So don't be shy for sure. The specific material that I'm going to talk about, and it's because it's what I'm most familiar with, is Myerson's DuraFlex. DuraFlex is a flexible partial material, very similar in look and feel to a Valplast or a TCS style or type of material, but DuraFlex is different. DuraFlex is a semi-crystalline thermoplastic. It is going to have a lot of flexibility to it. Nice thing about the DuraFlex is it's a polypropylene. It's not a nylon, which a lot of the other materials in the industry are nylons. Polypropylenes are nice because they have a melting point. Other plastics, like the nylons, they just get softer as they get hotter when you inject them. DuraFlex actually has that melting point that's well above 300 degrees. So that's why the DuraFlex mills so nicely, is because of that. So if you had a wet mill, you can control the heating of the nylons and them melting and winding up on your tool or breaking your tool. But if you have a dry mill, it can be a challenge to get a job done with any kind of efficiency. With the DuraFlex, because it is a crystalline plastic and does have a melting point, you can be very aggressive with a dry mill and not worry about it melting and causing problems with your job in your mill and breaking those expensive tools. Also, it doesn't absorb moisture or almost zero moisture. And so when you deliver this or the doctor delivers this to a patient, it's going to not get stained and look gross over a short period of time, which nylons can do because nylons are hygroscopic, which means not only do they allow moisture in, but they will actually pull it in. So all in all, it's a better material, and it's actually a material really suited nicely to milling. So you can see also aesthetically, they're really nice. This is a Nesbit here. And you can kind of see how it blends in. The translucency allows it to really, even in this extreme close-up, hard to recognize where the partial starts and stops. So what we're going to go over today is the design, specifically in Exocad. We're then going to talk about how is the relationship with the doctor, the workflow with the doctor as far as try-ins are concerned, and how that kind of goes. And then nesting. There is some things you want to do in your CAM software to make sure that you get a good fit between the tooth and the base. And I'll kind of give you the experience I had with that and what our experience is now with some of the changes we've made. I'm going to show Millbox as well as Hyperdent, because those seem to be the two most popular, and I'll kind of show you what we do in each one of those CAM softwares. And then the milling, I'll talk a little bit about kind of the offsets and the size tooling to be used, and how we've worked with Millbox as well as Hyperdent to kind of come up with milling strategies to be efficient at milling these materials, because that's a biggie. Big drawback in the past was taking 2 or 3 hours to mill an appliance. Now we've gotten it down to about an hour in most of the newer mills. And then milling or printing the teeth. So you have that option. So you can either mill the base, mill the teeth, or mill the base and print the teeth. And we'll kind of talk about how that works and what I would recommend and what I've seen. So what I'm going to do first, because it's the start of everything, is I'm going to jump into the design. And so let me back out of here. So the first thing I want to do is go over, making your order. And so the first thing that you want to do is whichever tooth is going to be part of the partial, I want you to select that tooth, and I want you to choose partial denture. So it has a picture of a cast partial frame kind of, but don't let that mislead you, because it kind of does both. So choose your partial frame option, and then you want to choose flexible denture. All right, and you have other options. These go into kind of the framework side of things, and maybe later we'll do a webinar as it relates to the Zerlex acetal and the doing a framework. But today we're going to talk about just the flexible denture options. So this is what you want to choose. Here you have your option of your base. You're going to mill it, right? And so there's just certain parameters and settings in here, being that you're going to mill that base. There's no real printed option yet for this material for sure. There's some out there, but we're definitely going to be milling this base out of the DuraFlex. And then you move down to tooth. What are you going to do with the teeth? Are you going to print them or mill them? And again, it's just settings, because when you mill, there's limitations with the size tooling you use and stuff, and it'll bring those into play. In this instance, I'm going to go ahead and we're going to 3D print that tooth. And then you'll just mimic that on each tooth. Now, this right here is your telling the software that these teeth are going to be splinted together. And I would recommend that. You don't have to do that, but we are going to still be mechanically bonding these teeth to the base. And so if the teeth are splinted together, that's going to make for them all working together to stay put in that base. Because that's always a struggle with flexible partials, is the fact that that you're dealing with a mechanical lock between the teeth and the base, not some sort of a chemical adhesion. And so I like to splint those together. And then you'll move over here to go over to your design. I already have it uploaded here. Now, the first thing that the software is going to do is have you position it as it says here. So you're looking down on a occlusal view. Now, generally speaking, most people just kind of position it. So I'm looking at it and hit next. I would take a little time, kind of visualize at this point the path of insertion of the partial, or how that partial is going to drop down over this patient's arch. And so kind of expose undercuts evenly by teeth where the clasps are going to be. And this looks good. You don't want it tilted like this. Now, it's not the end of the world that you were to be off at this point. It just makes things a little bit easier as you move forward, I found. So try to get this position nicely, spend an extra few seconds to make sure you do, and then move on to your next step. So what the software is going to do first is create a bottom, all right? And so it wants to block out and create a refractory model, if you will, for people who have done cast partial frames in the past. And so it's going to give you block out. If you look here at the bottom properties, it has this smoothing. And so what it's going to do is take any sharp areas, any real sharp creases like at the next to the teeth, and smooth those. The default is 17. I like to do 4% smoothing. It's just a little bit softening of the edges. So when that partial goes into place, there's no sharp areas that you have to like grind smooth, or that could affect the part, like the patient's tissues and pinching, and kind of, it's just going to make for it to be softer and smoother on their tissue. The milling diameter, I like to set at 0.8. The smallest tool I use is a 0.6. And so 0.8 gives you a little breathing room. And so essentially what this does is, if you have a sharp crease, like what's right here, and your tool is this big, what it's going to do is it's going to open up that space so that tool does relieve everything that's necessary. And so with partials, I like to give that just a little bit more breathing room from the size tool that I'm using. Now, play around with this. Your milling machines are going to work different than mine, possibly. And so this is just what I've experienced with my milling machines. And just to give you guys some insight, I have a VHF milling machine that's the S2, which is like the S5, but it's an older version. I have it like 7 years and it's still cranking and doing great. I have a 52 DC that I've had for 4 years. And then I have a 53 DC, which I've had for 2 years, something like that. And this setting seems to give me consistent results with each one of those milling machines. So block out, now it has it at 0.1% block out. You can move that really with flexible partials. The tip of the clasp is going to be in 95% of the time the deepest undercut. And then I'll talk about kind of how we adjust the block out from there. So I just leave that and I hit, apply. Now, because we positioned it, I could have changed the view and affected these blockouts differently, but because I adjusted that from the get-go, it really is exposing very balanced undercut. You can see here, and it looks very similar on that too. So I've really got my path of insertion really good, but you could change it at this point. That wouldn't be a problem, changing that. And so what the software is doing now is taking all those parameters, that's softening the block out, and it's creating that refractory model. Now you might see on this model, this indent, like a bead line. If you do a bead line, I would recommend that you do a bead line very faint. Don't go very deep. There's definitely times where I won't do a bead line at all. And the reason that I recommend that is when you do a bead line, the idea is to really seal it into the tissue. But we don't know where that's hard bony tissue or soft squishy tissue. And let's say right here it's really bony and I have a deep, normal deep bead line. Well, acrylic partial is going to just smash that tissue out of the way. The patient will probably have a sore spot there for a while, and eventually that tissue will kind of form to that partial. Or if it's metal, it'll smash it out of the way. I mean, we've all seen repairs come back where literally there's an indent in their tissue from their partial on the impression. And so flexible partials, the reason that they're so comfortable is because they flex and move with the mouth and the body. And so putting a really heavy bead line in there, I think can be possibly cause a bounce on this tail end. So the doctor puts it in the mouth and there's this little bounce on the tail end. And what's happened is it's flexed around that bony area, didn't sink in, didn't smash that tissue out of the way. And then the rest of that is kind of out of whack. And so that's why if I put a bead line at all, it's very faint. So do as you may, that's my experience with it. So here's our refractory model. You see there how I had to come up with something to filibuster where my computer works. With this, it's done that hint of a blockout. And so if you look here, over here, I'm going to go to freeforming, and that's going to allow me to manipulate that preset refractory base. And so if I hit shift, not only can I make my bubble or the area that I'm going to affect bigger and smaller, but if I hit shift, it'll take away and expose more undercut. If I don't hit shift, it'll actually add undercut. All right. Like I said, 95% of the time, the tips of the clasp are going to go into the deepest undercut. Right. Here's where you want to worry. Now, this is a free end, so the partial will flex back and into place, but generally you'd want to add here and take away any undercut so that you have a clean path of insertion. Over here, I'm going to hit my shift and I'm going to remove the undercut, right, to expose more undercut. Same thing over here. But this interproximal here, I want to add, especially because I have an abutment tooth. So the partial can't move backward. It has to go on this tooth, it has to go on this tooth. So these interproximals, they're going to fight each other. So I need to make sure that I don't have any undercut going on here. So we have a nice smooth path of insertion. This is where your finisher will love you if it's not you, and you'll love yourself. Because these partials usually will drop, just a few touches here and there. Once you really, get a little experience, and, I would recommend, if you have the ability to, if you're designing or if you have a designer, have them design and then have them fit those bases down, or work with the finisher to fit those down. And I'll tell you what, that person doing those designs will really dial in their undercuts quickly. Whenever they have to kind of fit those down into place. The softening, you can kind of see that softening here. I like, if you're going to have like an apron here go along, just in these interproximals, I'm going to hit my shift and I'm going to remove that. All right, you see how it's giving it a little more precise and crisp area. I'm not going to do an apron on this one, but that softening is going to affect everywhere. And what would happen here is once you milled your case and you fit it, you'd have just a little gap at the tip of those aprons as they go up in here. And then of course, when that patient takes a big bite of bread or something, that food's going to jam into that gap. So this will make so you have a nice point that really adapts nicely up into those interproximals. Once you block out, you can go here and hit the smooth and flatten and just kind of give it a swipe. So I'm hitting no keyboard, I'm just clicking over, and you can see how it's smoothed out that joint. Again, once we get this case finished, that clasp is going to be down upon the tissue. And so I want to make sure that if there's going to be a little movement of that partial up and down as they chew, it's tissue supported. We don't want those clasps. The reason that we're going to make our clasp go down upon the tissue is not because we want to gain retention from the tissue. We want to rely on just where it's contacting the tooth for retention. The reason that we go down upon the tissue is because the wider we go, the thinner we can go. All right, so hear me on this. The wider the clasp is, the thinner it is. The thinner the clasp is, the more aesthetic it is, the less food gets caught on it, the less it rubs the patient's lip. So a flat clasp is better in all different ways that you can look at it. But in order to have it that thin and it not be flopping in the breeze because it's too flexible, is we got to make it wider. So when it's on the tissue, we want it to be passive. So as it moves up and down, it can rub on the tooth. It's going to do absolutely nothing to enamel, but you don't want it rubbing on the tissue, or especially at that juncture. And this is where, flexible partials really go awry, and where people complain, oh, they strip tissue and they do all this. You just got to use common sense and design them appropriately. And so this is where I'm making a passive fit. This has already got 4% smoothing. So we're already ever so slightly passive here. Not so passive that we're going to get food caught or anything like that, just so there's a little breathing room in between that clasp and that tissue. And so when it moves, it doesn't rub it. So once we've exposed our undercut and we're happy with everything, and you could even go in here and expose that bead line a little bit more, you have total control over that base. We're going to go to next. And then we're going to follow the instructions here. So it's going to have us place the 4 and 5. And so you can choose, but it's having us do the mesial contact of number 5. So the actual tooth you're placing right there, and we're just going to stretch it across. Now, we're not putting them in any kind of accurate position. We're literally just kind of telling the software this is where they're going to be. And then we hit next. And we're going to do the same thing over here. And we're just following number 12, contacts number 11. And we're just going to drag that until we get about the size we can affect this, and click again, right? And you can see those teeth are way angled weird. That's fine. You could also go in here and you could choose between different molds if you want, and it'll change these, just multitude of different ways. We'll just stick with this, it's like a Exocad generic, I think they call it one. So then it's going to bring you to next, and this is where you get more precise in your position. So you have simple, advanced, and chain. It always starts you in chain, which I agree with. Any dots that are red, so if I move this here, it's going to stick those outer circles. If I take the red off, now I can move this as one whole unit. If I grab hold of this blue disc, so leave those red. If I grab a hold of the blue disc, it allows me to make them smaller and bigger, and kind of position them, appropriately for what we're doing. All right, we'll go around to this side, same thing. We'll move it up. We can kind of see that discs are nice because they hang out, so I can kind of pull it down. Now, I don't have opposing in here just because we're doing, this is just for example. But of course, if you had the opposing, you'd kind of position them so that aesthetically they're, or anatomically meshing in with the opposing. But that kind of looks good. I'm over top of the ridge. Size wise, can make it a little smaller. You could, so let's say you think the molars are a little big, these teeth are about the right size, you can lock those two teeth in and then just make the molars smaller. There's a lot of things you can do with that chain mode. But I always, once I'm done with the chain mode, I always jump over here to simple. And then the simple is each individual tooth. So now I can hit control and I can wiggle these teeth around. If I don't hit control and I just hit my left mouse button, I move it just, back and forth, up and down. And then I hit control and it keeps it where it's at, but lets it just wiggle around, right? If I move to my shift, I can make it bigger and smaller. If I hit shift and control, I'll just make it bigger and smaller in a specific direction. All right. So I can make these a little, bigger, smaller. I can kind of tilt. And believe me, it's like playing a video game, which I don't do a lot. My sons sure do. And they say I would be like outstanding just from, my kind of working on the keyboard day in and day out. But you can go around and you can really position these nice. This is also when it's nice digitally designing dentures, because you can really, especially if it's an immediate denture, because you can literally just position teeth wherever you want, cut them off where you want. You don't have to grind your fingers to the bone trying to grind teeth down to next to nothing to fit them in. The software will kind of do it for you. So I'm not going to spend a ton of time, but generally I got them in a position I want. Then we move on to the next step, which is even more fine tuning. And so here you have cusps. So it's very much like it sounds. You got a cusp here. You can move it over to the left and right. You can shrink it down. You can do whatever you want to with it. Tooth parts. Now you notice I'll click in the same spot, but bigger area moves. Entire tooth. It's going to move everything but the very bottom of the tooth. And I will give you a little hint. If you hit tooth parts and then you flip your model around, you can actually move that bottom. Now it's interesting because if you click right on past that edge, you'll move the whole bottom around. If you click just past that, it'll just move that specific area. So that one's nice because if you get past everything's good to go and you went, man, that tooth it's a little lingual too much. You can click on the entire tooth, scoot it out, and then go to tooth parts, go to the underside and scoot it out with it, and just kind of correct things from there. And then ridge is just as it sounds. If your ridges aren't kind of matching up, it'll just move that specific area, or a triangular ridge, you want that to be up and down, or a much smaller area. If I move over here to free, now it has like add and remove. So I don't like how these are pointy. So I'm going to go to add remove. And I'm just going to click on those areas and just kind of add a little material here. And then maybe I'll go over here to smooth and I'll just kind of round that off. And now they look a little nicer to me. If you go to the add remove, and like I said, I just click and add, you can see I'll put a big old bump on there, right? You can always hit the undo button. If I hit shift and click the same thing, I do the exact opposite and I put an indent in there. All right, and so that's the add remove. The smooth and flatten, if I just click this and I go around, it just kind of smooths it out. You see how that surface is just, it's taking what's there and just kind of smoothing it. If I hit the shift while I do that, you see it more abruptly flattens. And you see that doesn't just take what's there and make it smooth. It actually takes material away and flattens it. And so that gives you a nice overview of the tools once your teeth are set. And so what I'm going to do next is I'm going to adapt. And so the basal is the underside of the tooth, and the interproximals are, the interproximals. And then if I had an opposing, it'd have occlusion, and you could adapt the occlusion. And so what I'm going to do is I'm going to adapt. So what it's telling me here is later on, this is going to kind of happen. So you might not need to do it now, and it could possibly cause problems. I haven't found it to cause problems, and I do cut it now, and I'll show you why. This is a little bit of a experience thing that I kind of experienced. So I'm going to hit OK. And what it's going to do is this area that's poking down through, it's just going to cut it back. Now, I used to tell people with older versions of the software to do this at about a millimeter, so that it would not only would it cut back, but it would make about a 0.5 millimeter daylight underneath the teeth. The reason that I don't do that anymore is because in the newer editions, it will adapt the contact here and the bottom. And so if I have a 0.5 millimeter, it'll cut away a 0.5 millimeter off of these sides. And so I found is if you just do it at 0 to get you in the neighborhood, and then you got to finish the rest manually. So you can see there's nothing poking down through. If I take away my jaw, it's adapted that to the ridge. Now, all these sharp areas I do not like. Later on, it'll kind of cut and smooth a little bit, but you'll still have pretty sharp areas. And when you mill the bases, it can be challenging for the teeth to fit nicely if you have a lot of sharp edges. The mill kind of tries to deal with that, but I would say probably 80% of my teeth fitting into the sockets have a wobble or need some adjustment to get them to sit down in the sockets nicely if I have sharp edges. If I don't have sharp edges and I do some things in the CAM software that I'll show you, I'm finding like 95, 98% of the time they drop right in. And then there's a small percentage where I have to do some manual grinding in the sockets. So now we're to the ridge. I'm going to go to my smooth and flatten, and I'm going to make my tool real big by holding down the shift key and rolling my roller on my mouse. And I'm just going to smooth that bottom, right? I'm going to create space, and I'm also going to make it a nice smooth surface. Don't go crazy yet. Now, I've done this case a bazillion times in designing, so I'm going a little, I would kind of take this and, go back and kind of bring back your model and kind of see where you're at. But what I want to is, you saw in some of the earlier slides of the DuraFlex, it's very translucent. So you don't want a big neck of the tooth hanging down below where the natural neck of the adjacent teeth are. And so what I want to do is go in here, and again, I'm hitting the smooth with the shift. And I'm just going to take away a little bit from the facial. That's without the shift. So I'm just smoothing that surface without shift. And I'm going to go back here. I'm going to take with that, clicking on that eye, and I'm going to go to the lingual, and I'm just going to smooth it from there. All right. Now, the second thing I'm going to look at is I'm going to go here to the lingual, and I want to have a nice gap because I'm going to have material going under these teeth and connecting to clasps. And the only material that's supporting this whole flange is what material makes it under these teeth. So if this is paper thin under here, there's going to be way too much flexibility, and that whole facial flange and clasp is just going to be flopping in the breeze. It's going to be too flexible. So I want to have a nice amount of space under there. You can see on this side, this is not too bad. I'm going to hit my smooth. I'm going to bring that up off of the bottom there just a little bit. All right, I want to open up this lingual a little bit. So I'm going to go back to my smooth. And this is all very important because, the weakest link to this partial is going to be the joint between the teeth and the base. And so I want to make sure that I have a lot of material there, a lot of strength, and a lot to work with for mechanical retention, which we'll show you later. All right, if you're touching a little bit, you can hit the add remove and kind of take that away. That's telling you you're touching the model, and that's fine. It is going to adapt later, so as long as you get it close, you're in good shape as far as that's concerned, because it will adapt off of a certain distance. I'll show you where those settings are. So that looks pretty good. Now, here's where it comes to a bit of a workaround. So I'm going to take my model away, and I want to position these group of teeth so that I'm kind of looking directly down at the bottom of them. Over here, it says Add Custom View. I want to click on that. So now, no matter what I do at this case, if I go to Custom View 1, it's going to bring me right back to that original view. And that's important because what I'm going to do now is add some mechanical retention. So over here under freeforming is the attachment, all right? So first thing I want to choose is subtract, right? So this is the attachment. So this is like if I wanted to add on a keyway attachment to a bridge, or if there's just multiple different ways that you can use this attachment. In this instance, we're kind of using it as a workaround. What I want to do is subtract. I don't want to add an attachment. I want to subtract an attachment. So I'm going to hit subtract. I'm going to hit this down. Now, you can see it's already on generic, but I actually want this generic right here. And under default, I want cutout. All right. So again, subtract, hit the down arrow under library and hit the, not the generic that shows, but the one down in the list. And then I want to choose the cutout. All right. And so here's what the cutout looks like. It looks like just a tube. And that's what we want. So what I'm going to do is position that right on the center of the tooth. I'm going to make sure I'm at my custom view. Over here, we have move, rotate, and scale. I want to click on scale, and I'm going to make this bigger. I'm hitting the shift key, and I'm just towards the arrow, I'm just making it bigger. So make it nice size to fit inside the tooth. I'm going to turn this to the side. I'm going to go up here to anatomic shapes, and I'm going to make that so I can see through it. And I want to be up in the tooth, not crazy, because there could be some occlusal adjustments and you could bump into this. I just want it to be up inside the tooth a few millimeters, and that looks like a really good position. Let's go back to custom view. You see how there's a little shadow there? I want to go to rotate, and I want to hit shift, and I want to tilt that just so there's not much showing. It doesn't have to be perfect, but that. I'm going to hit apply. And then it's going to give me another one. I'm going to put it there. Now, of course, that's big. So I'm going to go back to scale. I'm actually going to hit shift and control, and I'm going to make it oblong. And then I can do just shift, and I can make it a little smaller, right? So fit inside that tooth. I'm going to take away the brightness. You can see we're way up high. So I'm going to go to move. I'm going to bring it down so that I'm up inside that tooth just a bit. I'm going to go back to my custom view. Right, there's a little shadow, so I'm going to go to rotate. I'm going to shift and just tilt that so there's not much, if any, shadow. And then I'm going to apply. Now I'm going to go to the next tooth. Now, so if you hit rotate and you don't hit anything, you're just clicking your left mouse button. You can twist that to fit into that tooth. I'm going to take that dim off. Again, way high. Let's go to remove. Bring that down. Let's kick it to the lingual a little bit. Let's make sure with our custom view, we got a little shadowing there. So let's hit shift and tilt that a little. That looks good. Let's hit apply. Now we'll go to this tooth. We will rotate, hitting shift. I'm sorry, not hitting shift, just hitting my left mouse button. Take away that dim, go to move. I know this is monotonous, but I got to go through it. It's good for you guys to see it over and over again. You'll get really fast at this. I would say Logan does most of my designing, my son, and he'll get through a case like this in 20, 25 minutes easy. Once you really get efficient at it. Let's make that a little bigger. Hit apply. Let's rotate. So I'm going to go back. You see how I didn't straighten that one? All right. I'm going to go ahead and finish this one first. And then we'll fix that one up. All right, let's go back to our custom view. See, that one's way off, so we're going to hit rotate, hit my shift. All right, that looks good. We'll hit apply, and then we'll go back over here. Let's get that straightened up. Now, the reason that I straighten all these up is because later on, the software is going to ask you to block out the teeth in their sockets. So it's going to ask you, to block out the socket the tooth is going to go into, so those teeth will go in and out properly. And of course you want to do that, right? Because there is going to be little undercuts and little deviations. And for dentures and partials and everything, they can be extreme. With this, because we're creating these retentions, it amplifies that. And so we definitely got to have a block out. And so if we make these all parallel, there's not going to be much for it to block out. If they were going in all different directions, well, now the software is going to cut off half of our posts just so the unit can go in and out of those sockets. So that's why we want to line this up as close as possible to level. So we'll hit apply, and then we'll go to next. So now it's going to move us into actually designing the partial once we've got our teeth created. So here's our default for our thickness. So our base thickness, we want to be at about 1 millimeter thick, right? And our cervical thickness, I'm going to show you later. I like my cervical thickness to be a little fatter right as the partial ends for comfort and for adjustability for the doctor. And I've tried to make the cervical thickness heavier, but what it does is it makes the cervical and it tries to faint it slowly kind of transition into the base. And I don't really want that. I just want a kind of nice roll at the edge. So I do that manually. And then the smoothing at 2 millimeters is good. That's just like the rugae and the different things showing through, it softens all that. So 1 millimeter and 1 millimeter is good. And so now you just are going to create your bottom. I'm going to do something a little different than the scribe line shows back here, just so I can demonstrate something. But I'll go ahead and follow that. You can be real precise in doing your spline, creating this, or you can go real fast like I am and then go back after and kind of correct. And so that's what I tend to do. I'm going to go across and do kind of an apron here or a strap. And again, I'm kind of going quick. So at this point, you can leave it unconnected and just go around and you just click on each individual little, slump spline piece and kind of adjust it. Or you could have accepted. The only thing that stinks about accepting is it works for a little bit creating your base. And it's not bad because you can kind of look at it and make sure that it's, everything you wanted. But I just don't want you guys to wait around kind of accepting it twice. So I'm going to go ahead and not connect it. I'm going to clean everything up a little bit. And again, the wider we go, the thinner we can go. All right, back here, you can see I'm totally covering this tooth. I'll show you why in just a little bit. All right, so now I'm just going to double click, and that's going to kind of accept that design. The only thing that's tricky about that is if you ever forget to double click and you move to next, you have to start over again. So it's a real pain. And it's weird because the denture module, it'll allow you to create the spline and then adjust it without accepting it and going through the work that it's doing now to actually, create the major connector. So it would be nice if Exocad could do that. And I guess probably going into the settings, you might be able to do that yourself, but I haven't, or that's a little above my pay grade, I guess, as far as what I know. So what it's doing now is just going to create my bottom using those parameters in the spline I created. The software has gotten a lot better at adapting up to the teeth. So it used to be I had to do a good bit of work, especially if there was a lot of distance between the teeth and the ridge like that there. That's a pretty good distance. So it didn't quite go up there. I mean, it's easy to fix, but it's because, it's used to like acrylic at like 2 millimeters. And this is only a millimeter thick, it can be much more dainty. And so we're going to go to next because we're going to accept that. And now it's going to let us kind of fix this. And so you can go to the large region and you can pull a much bigger piece of the, the partial kind of move around. If you go to the small region, you can see it pulls kind of a more smaller individual area. If you go to free, you can just, again, it's just like before, you can just add to it as you go along, right? Or you can go to the smooth and just kind of go, everything is the same as how, we kind of already, showed things. I do like using the large region, but if you go across, you want to pull a little bit, and you see how I'm moving down. If you go to pull a big part, you'll get this like peak of material, and then you're going to try to smooth, and it just kind of is a pain. if you start out that way. So I'm just going to move myself down, moving little inches at a time, and just kind of move that material up. I'm going to do the same thing out here. And again, the angle, you'll get good at angles, but you see how I'm kind of looking down on it. So I'm pulling it up and out kind of at the same time. And I'm not going to get super, pretty with this just for time's sake, but you'll get the drift. So now once I've pulled everything, I'm going to smooth. I like to go to the tip of the clasp and I'll just hit that and smooth that. Again, you can take it to whatever level you want. Some people like to put their hands with a handpiece on it at the end, so they don't really bother thinning the clasps out and doing a lot of that stuff, because they're just going to kind of do it, at the end. So here I'm just adding, and you can do kind of rude eminences, with this. You can really do some pretty work. You can see I like to have the linguals have some coverage, and you can see I'm kind of bulking this up, but then I'll go over with the smooth, and it kind of takes that bulk and kind of spreads it out, if you will. All right, same thing over here. We're going to create an undercut in the lingual, and so with that, you want to have some material of the base kind of covering the lingual of those teeth to work with. And this is not undifferent than any partial you would design. All right, so one thing I'm going to do here is I'm going to go up to my anatomic shapes, which are the teeth. I'm going to dim them down. Now you can see our posts inside. I want to make sure that the material is touching the roof of that post. You see that? Let me take that tooth away. See how I made that post go up? In a little while, we're going to adapt. And when we adapt, the software, if it's not touching the roof of this post, it will kind of go, oh, I'm not really supposed to go up there, and it'll adapt flat, and it won't adapt up into that post. So you just got to make sure that you add enough that you make contact with the roof of that post, so the software knows that it needs to go to there, right? All right, so again, I can make this prettier, but I'm gonna end it there. Now you see this tooth here, you're like, Kris, what are you doing over there? Like, it's totally surrounding that tooth. Well, here's a little workaround to create a ring clasp. Now, right now, if I was to hit the add remove and go over here and go, yeah, let me just expose this. Well, you see, as I start to expose, it stops me. That's not the tooth. That's the minimum thickness of the material that the software allows. And you need that because you could go thinning areas and make it way too thin. And then you mill it and realize, oh, shoot, this was only like 0.2 of a millimeter thick or something, right? So you need that. So what I'm going to undo that to put it back. What I'm going to do is I'm going to take off, keep bottom boundaries fixed. I'm going to take off the minimum thickness. And I also take off, this is just showing you how thick it is because I don't need that now. Now, if I go to add remove and I remove this, it'll let me go right on through. So the reason that I get the partial pretty well done at this point is because if I have to go back and turn on the minimum thickness, any areas I hit over here, it'll take it back to minimum thickness. So in other words, if I have keep bottom boundaries in this, and then I just click one time in this area, boom, you see that it adds it back. So you want to make sure you're kind of done with everything before you kind of do that, so that it just makes your life a little easier, especially if I have multiple of these and stuff. That's just, again, a little tip. So I'm just going to go along here and smooth this out. All right. So do you see this right here? So all digital scan or files have an outside and an inside, right? What we're going to eventually make is a solid, but for digital files, you have an outside skin and an inside skin. And what I've done is I've pushed the top skin through the bottom skin. This is something that'll possibly keep you from adapting and give you an error, and you won't know why you're getting an error, and you'll try to adapt the teeth to the base and it'll say error, and you'll change. and you'll do it again, and you'll be scratching your head and frustrated. This is one of the things we found, is just go on the underside and add to the underside skin so that the skins aren't underneath each other. Now they got a little gap between them. That right there, model showing through, is another thing that I found will give you an error. So again, you want to add material there. It's going to adapt to this. So, it doesn't matter. So you want to take a peek around and make sure there's no other parts of the model kind of poking through. Also, if you were to add here, and you see let me show it better here, that the base is poking through, that can also give you an error. So let me take that away. And those are a couple things to look for. So now if we go to next, it's going to ask you to add your contacts, your connectors. You can do connectors. I found that if you hit the X, which is, let me show you, it's just going to connect where the teeth are touching. And it'll make a small little connector. You can add to the teeth to make that broader. But that's what I found for adaption, the nicest, because there's no real connector there. But you can have bigger connectors. That's fine. All right. Here's your settings. So you can see it's automatically going to block out a 0.5 millimeter under the teeth. So if you weren't quite totally relieved from the model, it'll do that at this point. Tooth pocket, I like to be a 0.3. I want to have a nice gap for the bonding agent we're going to use. And then you want to block out tooth pocket undercut. That's what I was talking about. And yes, you need that so you get the insertion fine. Let me scroll this down. So bridge, consider bridge tool diameter. That's for the teeth. We're going to print them. If you're going to mill them, you probably want to leave that on. But I'm going to take that off because we're going to print them. And there's no limitations on printing as far as undercut and stuff. And then smoothing the basal area, I want to move that to 100%. I want that nice and smooth. But I do want to consider the tool diameter for my base. Kind of already did that. And remember, I want to move that down to 0.8. All right. And those settings seem to work good for me. And I'm going to hit apply. Hey, Fran, if there's any questions or anything you want to add at this time, is a good time.
Sure. So far, no questions are coming in. I know that one of our attendees, Mohammed, raised his hand, but that function doesn't work. I sent you, Mohammed, something in the chat. So if you have a question, just type it in at the Q&A section at the bottom, and we'd be happy to answer any of those questions. But just want to let everybody know what's happening. Next up on Zan Academy, since this is going to be adapting now, we have 8/13, so that's next week, mastering the zirconia workflow with Steve Klein. And he's going to be talking about calibration to consistency with zirconia. And then on August 20th, we have Dan Morano coming back from Morano Dental Arts. He's a CDT, and he'll be talking about utilizing all of the tools in your digital toolbox. So that should be pretty interesting as well. And I just want to let you all know that Kris is going to be joining us again at our next roadshow. That'll be on September 18th and 19th in Lexington, Kentucky. So if you're anywhere in that area and the surrounding areas, we'd love it if you joined us. We're going to have a day of Exocad training on the 18th. 2 hours of getting started with Exocad, along with a single crown design. And then in the afternoon, a 4-hour course on All on X. The next day will be our roadshow, and at the roadshow, we have about, I would say, over 15 manufacturer partners that are going to be joining us for kind of like a mini trade show. And all of the lectures will be, based on different types of demonstration. So we're really excited to be back in Lexington. We were there probably 2 years ago, and it's such a beautiful place to visit. If you've never been, join us. And then in October, we'll be heading to Dallas-Fort Worth, and that'll be on the 23rd, 24th, kind of like the same exact roadshow, just in a different place. So we'd love for you to join us in either of those beautiful cities. And I think we do have a question here.
All right.
So, one of the attendees wants to know if there'll be a session on how to post-process and finish these materials. And I would like to say yes.
Yeah. So I'm actually going to talk about it a little bit here. But yeah, we'll talk about, just so you have an understanding of those road shows. We're tables, right? So there's presentations, but there's times to just kind of talk and go over different things. And so Exocad will be there, 3Shape will be, I mean, at least the last one, 3Shape. I think 2 or 3 different printer companies were there.
Oh, yeah.
There's a nice variety. It's not like, all of us get along, all of us answer the questions and let you make the decision on what suits your lab or what material or equipment you already have and kind of can use better. So it's a nice setup. It's definitely good. But yeah, if that's everything, Fran, we're all calculated and I can kind of show it.
Perfect.
Yep.
Thank you.
So here's our teeth that are adapted to the base, right? And you can see the sockets, and this is it's anticipating the milling machine. So it's created little points. So the milling machine for sure is going to reach those areas. And, on the bottom, you can see it's no longer poking through. It's adapted, to that base. And one thing, and I kind of forgot to do that, I talked about it. I do like to go and just add to the border to make that a little bit heavier. The reason I do that is twofold. One, flexible partial materials aren't sharp like acrylics. Like you guys know, you have a pretty sharp piece of acrylic, it can cut your finger. Flexibles are softer than that, and they won't really do that. But in the mouth, they can still feel sharp to a patient, like with their lip pulls and it pokes. So rounding that is important. Also, doctor may have to grind from the underside. And if you don't have a little bulk of material for him to work with, he could grind that to a nice fine edge. And then the patient complains of pain and he grinds. Next thing you always ground the thing to next to nothing. So bulking up those borders is important. All right, so let's minimize this and go back to the presentation just for a little bit, and we'll kind of go over some things. So taking it now from a design to milling using Hyperdent. Really, it's nothing crazy. You want to choose partial RPD. The one thing that is different is you want to choose margin line, which sounds crazy because you're not doing a crown. But what a margin line does in there is it encircles an area saying, hey, mill, I want you to make finer, more precise passes in this specific area. This specific area needs to be highly accurate. And so we're going to choose those and we're going to mark the perimeter of those sockets. So the rest of the partial, we're going to be polishing anyways. It doesn't, it can have some fine striations from the tooling. So it doesn't have to make fine passes, which will dramatically speed up your process. But in these sockets, I want you to use the smallest tools and I want you to make the closest passes and really do a great job milling in there. For lack of a better technical terms, that's essentially what you're telling the software. Now, some things that we've been working on with Hyperdent and then as well as Millbox is some strategies specific to flexible partials. I am not sure if these have been automatically enacted into their software or you have to call your reseller and or Hyperdent and get them to activate them in your software. But you have the 3mm roughing and the 4. I recommend 3, the 3mm tool. The offset for a 4mm tool makes it so, and I'll show you an example of it in a little bit, but you really, it saves you 5 or 10 minutes maybe on your milling job, but your offset you have to create really takes up a lot of room in the puck. And we all have to be concerned with costs, and being able to fit 2 partials for sure in 1 puck is definitely a huge advantage over maybe saving 5 or 10 minutes of milling time, but only being able to fit 1 partial in a puck because the offset's so big. And I'll show you what that means in a little bit. So that's really the only difference as you move forward with this in your software. Now, if there is any undercuts, especially in the inside, that you want the machine to pay special attention to, you can use your draw user-defined areas and encircle those. And again, it's the same kind of thing. It's telling the software, look, you're going to need to use all of your degree of undercut angulation that you have to offer to reach these, but pay special attention to those areas. Your Supports, just if you think you put enough supports, put a couple more, especially on clasps. Make sure you really support those clasps because you don't want them flexing or rattling while you're milling. You want everything, it's flexible partial. While it's being milled, you don't want it flexible. And then here's your, whenever you calculate thing, it kind of lays out. This job was going to be 1 hour and 33 minutes. That had a lot of undercut on the inside, which if you encircle a bunch, that'll add time. And then the sockets will add time. Generally, most cases were anywhere from an hour. It also has a lot of surface area. Anything that's bigger like this is going to take more time. Lowers, this is an upper. Lowers are usually around an hour, hour and 10 minutes. Uppers are hour and 10 to hour and 30. It's probably the high end of time. Mailbox, not too different. Here's my offset I was talking about. This is the offset for a 3mm tool, which is 4mm of offset. For the 4mm tool, it's 6mm offset. You see, there's not very much room for another partial in there. So, my opinion, stick with the 3mm tool. You could even bump this down to 3.5mm offset. There's not too much undercut on the facial. Save a little more space. And again, you're going to go to your tools. You're going to go to your curves and surface tools. You're going to mark your margin line, very similar. This offset default is fine. And then you're going to mark your margin, very similar concept. And again, it's doing the same thing. And then you're going to process. One thing I will say, the 53 is kind of my workhorse with a lot of plastics. It was developed, for the Roland 53DC, much more robust spindle than the 52, and a much more rigid mill. It also has the open edge bracket, which is nice. They kind of came up with the open edge brackets so that you could mill the facials of all on X cases and things like that. What it really does for flexibles is allow you to protrude into an open space and free up, like these are two big partials. They would never, I'd never be able to fit two in a closed edge puck, because not only would I have to have some space there, but I would lose several millimeters. So that open edge bracket's really nice for making sure you fit multiple cases in one puck. So then once you mill, you can either mill or print your teeth. And these are printed teeth right out of the printer. You can still see the little bumps on the surface, and they'll just drop right down into those sockets, probably like 95, 98% of the time with no adjustment. All right. Then you're going to create a little lock on the periphery of the socket with a round burr, as well as punch some holes in those posts. Again, we're dealing with mechanical retention. We're going to have a little reaction, a little bond, but we still need to rely on mechanical. And then what I always say is whatever material that you use for making your teeth, use a bonding agent that will chemically bond to it. So for instance, this is Trusana, these teeth, and I'm using Trusana's bonding agent. If you use Lucitone teeth, I would use the Lucitone Fuse. So again, whatever material you decide to make the teeth out of, I would use a bonding agent that will chemically adhere to those teeth. So you aren't relying on any kind of, you're getting you're literally adding to the teeth, and then it flows down into the holes and the ledges that you put in the sockets and locking it in. And so this process isn't any different than doing a denture. You paint it into the space, work it into any of the undercuts, put your teeth down in place, clear out the excess, tack it with a light, and then send it through its final curing stage with the bonding agent in place. Nice thing about the DuraFlex is it's translucent, so that curing light will penetrate and do a good job at curing that. So again, thank you. I moved my lab about 6 years ago, and I had to clear out my drawer. I'm a bit of a pack rat because I always feel like, oh, look, there's a little space. I could do a little Nesbit there. And oh, I could do a little temporary in that Zerlux acetal or in a little Nesbit there. And I wound up keeping all these pucks and I can't stand to throw them away, but I wound up bringing them all out onto a table when we were moving. And I was like, good grief, I have a problem. I need to get rid of these things. But yeah, if there's any questions, I can answer those now.
Yeah, just type them in at the bottom of your screen. I do have a couple of polls, so I'm going to launch those now if you wouldn't mind. answering those. So the first is, would you like to add Exocad to your lab? So if you are a 3Shape user and you feel like you want to add Exocad, that's great. It's great having both. We have a great webinar on why having, both is really beneficial. So I'll just keep that up for just another moment, and then we'll go on to the next. And thank you all for answering. Really appreciate it. And thank you all for coming.
Yeah.
And for those of you that are Exocad users, do you need to renew your license or upgrade to do certain things? Or would you like to transfer your Exocad license over to Zan so that if there's anything that you need help with, our technical support team will not have a problem being able to get into your system and help you out. So there's that. We'd be happy to help you with this since we've been now, a dedicated Exocad dealer. It's been great. So thank you so much for answering that one. And of course, are you interested in adding any Myerson products like Acetal or DuraFlex that we spoke about today? And any of these questions that you've answered for us, if you answered yes to any of them, I'll be giving you a call in the next day or so, and you can talk to me about, anything pertaining to this webinar that we can help you with. It won't be anybody strange calling you, I promise. It'll be me. And I love it. I love talking to you guys. And Kris talked about the different mills that he has, right? So, we carry all of those mills. So if you're looking for a new mill, really we can help you with great financing option that I'll put up in just a few minutes, or a printer, anything that you're looking for. We do have now 0% financing for 12 months, which is something that's completely new that, our VP really fought for you guys. So this is definitely new, and that'll be my next question. So if you're interested in purchasing any equipment at all, we can help you out by getting you no interest for 12 months, which is really, really great. And basically, anytime that you are financing through us, Henry Schein, it's great because we don't affect your credit. We don't go through a bank. You're through us. It's one simple form. You find out in a matter of hours, of course, if you could finance through us. And with the 0% financing, you can also finance any type of materials as well through this particular, and that's through, the end of this quarter. So that's pretty cool as well. So it's not just the equipment. You could finance anything that you need, to get started with doing any of the workflows that you see with us. So I thank you so much for answering all those questions. And I thank you, Kris, as well as the Myerson team for bringing this great information. And Kris, I can't wait to see you in Kentucky. That's next month.
Yep, we will see you soon.
Okay, if anybody's in the area, please go on to, zandental.com, go to the education section, events, and you could register right through Eventbrite right there. We'd love to have you. So everybody have a great rest of your day, and thank you so much, and I hope to see you next week here on Zan Academy.
Great, guys. I'll talk to you soon.
Oh, wait, Kris, I think we have some questions.
Okay.
We do. Oh, Gabriel wants to thank you for your technical knowledge. And Gabriel, thank you so much for, joining us.
I appreciate that.
And yes, there will be a recording. He also wants to know if this was recorded, and it was. All of our webinars are recorded, and look into your inbox in the next day or so. You will find an email there that will have the recording. Everybody that registers gets the recording, whether you attended or not. So
and I will say, check out Zan's YouTube channel. I mean, there's been a lot of, if you're interested in Exocad, there's been a lot of nice education presentations done that are on there available. So that's a great place to go.
Thank you so much, Kris. We appreciate you. Thank you again. And thank all of you, and have a great rest of the day.
Great. Bye-bye.
Bye, everybody.